Hello and howdy, ladies and gentlemen, and welcome back to question number 2, question B2, on the 2016 Canadian Senior Math Contest. So this is the second of our written questions. It's also the second last. Hopefully you guys have given this a try. As I've said before, you can download a copy of this contest, and I really do encourage you guys to try the problems out before watching the videos to see how I do them. Alright, so question 2. In the diagram, the circle shown has center 6 and 8, and a radius of 10, and that's enough information to get an equation. X minus 6 squared plus y minus 8 squared is equal to 100. And the circle, most notably, passes through the origin. Because if you go out by 6 and up by 10, you get a nice little right angle. Or sorry, out by 6, up by 8, and the hypotenuse there is, in fact, 10, which is pretty cool. Pretty nice. You do the same thing with 3, 4, and 5. 5, 12, 13. Any Pythagorean triples work there. Alright, so the circle passes through the origin. Okay. We've got A, B, C, and D. So A, determine the coordinates of the point P where the circle intersects the x-axis. And I assume they mean intersects the x-axis other than the origin. So we might start this off by saying something like, let P have coordinates. It might have some x coordinates, but it's got 0 for the y coordinate. That's how we know it lies on the x-axis. Now, they give me an equation for the circle, so why don't we just use that? I think there's probably another way we could probably do this, maybe with some Pythagorean triangles and some circle geometry, but we have an equation, so why don't we use it? P is on the circle, so P minus 6 squared plus 0 minus 8 squared is going to be equal to 100. Well, P minus 6 is not a whole lot I can do with that, but 0 minus 8 squared, that's just minus 8 squared, which is 64. And subtracting 64 from both sides, P minus 6 squared is equal to 36. So square rooting both sides, P minus 6 is equal to plus or minus 6. Because there's two different things I can square to get 36. Plus 6 or minus 6. And I don't know which one P minus 6 is supposed to be. So P minus 6 is either 6 or negative 6. P then, we just add 6 to both sides, is either 12 or 0. But of course this would be the origin, because then it would be 0, 0. So it's got to be 12. So P has coordinates 12, 0. Okay? You know, if you're interested in a circle geometry way to do this, which, you know, I don't think you quite need, but if you're interested in a way to do this, one thing you could realize is, well, 0 to P is a chord of the circle, and so a radius intersects the chord at 90 degrees and splits these two in half. But the 90 degree here means it's a straight down line because it's perpendicular to the x-axis, so it's parallel to the y-axis. So the x-coordinate doesn't change, so this intersection point right here is going to be 6, 0. The distance between the origin and this intersection point is 6. So the other side's got to be 6 as well, and that gives me 12. That's a circle geometry way to do it. And that is an equally valid proof. Okay? Just because they're giving you, coordinates, just because they're giving you equations, doesn't mean you have to use them if you don't want to. Okay? If you want to do circle geometry, that is a fantastic, quick circle geometry way to do A. It's not any harder or any easier. It's just, are we more comfortable with radii, midpoints, perpendicular intersections, or are we more comfortable with equations and coordinates? Both fine ways to do the question, though. So that's A. Cross that off our list. What about B? Determine without justification, that's pretty nice, the coordinates of the point Q on the circle that has a maximum y coordinate among all points on the circle. So we don't need to justify this, we just need to have the right answer. I would still recommend a little bit of justification, part marks, that sort of a thing. So we want what? The maximum y coordinates. We want sort of this peak, this highest point here. Okay. So we need Q at xy with y as big as possible. Well, Q is on the circle. So that means that x minus 6 squared plus y minus 8 squared is equal to 100. Okay, now, if y is as big as possible, then I would say y minus 8 is as big as possible. X minus 6 squared, no matter what it is, it's non-negative, since it's a square. You'll never meet a number that's, and somebody says, oh, it's a square number, oh, and it's negative. That's just not possible. So if that's the case, then that tells me y minus 8 squared, all on its own, is less than or equal to 100. You know, maybe maybe x minus 6 is a certain amount, and that brings it down a bit, but there we go. So if y minus 8 is as big as possible, then y minus 8 squared should be as big as we can make it. And so we let y minus 8 squared equal to 100, which is 10 squared. So I can either choose to let y minus 8, it's going to be plus or minus 10. I probably shouldn't have let, probably should say then or therefore. And that would be y is equal to, we'll add 8 to both sides, get 18 or negative 2. Now the negative 2, what's that doing there? That's actually the smallest point, the minimum y coordinate, which is also obtained by making as big a gap as possible and focusing on the y's as much as possible. But we want the biggest value of y, well, that's going to be 18. So y is equal to 18, and because we made y minus 8 squared equal to 100, x minus 6 squared has got to be equal to 0. So x minus 6 is plus or minus 0, but that's the same number. X is equal to 6. Therefore, Q is at 618, which is actually right above this center here. So there's Q. So that's B part. All done. We didn't need to justify, but we wrote some sentences. We explained a little bit of what we were doing. Okay? I think they were just trying to avoid people messing about with detailed inequality proofs when really that's not what we're looking for. So we got C and D. C, determine the coordinates of the point R on the circle so that PQR is 90 degrees. Most notably, specifically note that the Q is 90 degrees. So it's going to be, let's clear up our picture a little bit. So I know Q is right up here. So it's going to be P to Q to, I guess R is probably somewhere around here. But the 90 is at the Q, not the R or the P, and that's quite particular. Okay. How could I do this? Well, I could use some circle geometry if I wanted to, just like we could have in A. The 90 degree there means that we're going to be a diameter, so RP is a diameter, and we could use that information. P and C, like C is going to have to be on that diameter, and we could extend that line and figure out where R is. That would be fine. Another thing we could do is say, well, I know P and I know Q, so I can get the slope here, and then I can get the slope of the line RQ. It's just the negative reciprocal. And then because we know the point Q, we'll have enough information to get that line, and we intersect that with the circle, and we find R that way. Now, I didn't do circle geometry with the first one, so for people who like circle geometry, let's write up part C with the circle geometry way of doing things. So I'll draw a little picture. So Q is up here at the top, C is right here, P is here, and what do we need? Well, we want R, Should be about here. Okay, and we'll need to get a diameter. Okay, so we might say something like, since the right angle is at Q, we can see PR is a diameter. There's lots of ways to justify this further if you want. You could say, well, PQR is a right angle triangle, and the circle is therefore a circumcircle to that triangle, and you know, the circumcenter on a right angle triangle always lies on the hypotenuse, PR, that sort of a thing. But I don't think it's entirely necessary. This is basic circle geometry stuff. Justify it a bit more if you want to by talking about circumcircles, circumcenters, but you don't really need to. Okay. So we can see that PR is a diameter. So the center, C, lies on PR. So what could we do? Let's say the slope of line PC, which is really slope of PR, is, well, I know that C has y coordinate 8 and x coordinate 6, and I know P has y coordinate 0, x coordinate 12 from part A. And so we could say that's negative 8 over 6. That's negative 4/3. And just briefly, if we check out our picture, this blue line, this diameter, is going down and to the right, so that would indicate negative slope. So that tells me the line that is PR, which is the same as the line of PC, whose coordinate, like we have enough coordinates for P and C to figure this out, is going to be y equals, well, let's do it with point slope form of the line. So y minus a y coordinate is slope times x minus an x coordinate. Okay, so this is the equation of the line. So now let's intersect this with our circle. And if you didn't want to do this with the circle geometry justification, you could absolutely get the slope of PQ. Just briefly in my head, that would be 18 minus 0 over 6 minus 12. So that would be 18 over negative 6. That would be negative 3 would be the slope of PQ. So the slope of QR would be negative 1/3. And you could again use point slope form of the line and get a line. But now that we have the equation of a line that R is on, we just intersect this with the circle. So just quickly rearrange it. Y is equal to negative 4/3 x minus 6 plus 8. Just bring the 8 over to the other side. So now we know x minus 6 squared plus y minus 8 squared is 100, but I have a formula for y now. Negative 4/3 x minus 6 plus 8 minus the 8 is 100. Well, these 8s are going to cancel each other out. And look at that, we've got x minus 6 squared plus the negative 4/3 is going to become a 16 over 9. We get x minus 6 squared again. This guy here, x minus 6 squared at the front is really 1 times that, but we could write the 1 as 9 over 9. And now we've got the same fraction, so 9 plus 16 is 25. 25 over 9, x minus 6 squared is 100. Now I could divide by 25 over 9, x minus 6 squared is 9 times 100, 900 over 25. That's going to be 36. So once again, we get x minus 6 is plus or minus 6. X is going to be 12 or 0. Very similar to the very first question. This 12 here is going to substitute back in and gives us P. This 0 here doesn't give us the origin. It gives us R. And so we just need to work it out. Incidentally, I guess that means that R is the y-intercept. That's pretty cool. So y is equal to negative 4/3 0 minus 8, or 0 minus 6 plus 8. So that's negative 4/3 negative 6 plus 8. Negative 4, negative 6 is 24. 24 over 3 is 8. 8 plus 8 is 16. So R is found at 0, 16. Alright, so that's C part. That's all done. And now D part. Determine the coordinates of the two distinct points S and T on the circle so that PQS and PQT are 45 degrees. So we'll quickly sketch a circle there. Q up here at the top. We have P down here. C is probably going to be relevant. And we have PQ, and then there's some point S over here, and I guess another point T over here, so that both of these guys here are 45 degrees. Okay, it is the angle centered at Q in both cases. Okay, so that's what we need to work with. Now, once again, some circle geometry would come together and say, well, 45 and 45 is a big old 90. So notice angle SQT is PQS plus PQT, which is 45 plus 45, which is 90. So just as in C, we observe ST is a diameter. So that's pretty nice. The question is, where do we go from there? Yeah, it's a diameter, but how am I going to find this diameter? What's there to do? So the challenge is getting that 45 degree. Well, C is on the line, so how about we draw the picture a little bit better? We'll draw the circle a little bit bigger, I guess. So there's Q, there's P, there's C. I'm going to connect C up to each of these. I don't know why, I just feel the instinct to. 10, we'll put a 10 here. And then somewhere we have diameter S, T. Once again, we also have some 10s here. Now, there's lots of different diameters, but only one of them gives me a 45 split here. Which, admittedly, it doesn't look exactly that 45-ish in my picture, but 45, 45. Okay, so what can we do? What can we do? Well, to bust out some more circle geometry, I guess we'll use purple here. SP is subtended by a 45 degree angle. And that means that the angle here at T is also 45 degrees. I don't know if this is going to help, but this certainly looks like it might help. Similarly, this angle here is 45 degrees. And that gives me a 90 here. Well, of course that gives me a 90. ST is a diameter. I feel like the presence of some 45s is... I think there should be an isosceles triangle somewhere, but I can't really think of exactly where it is. Once I find S, I know I can figure out T automatically. Well, not automatically, but it's a diameter, so I can quite quickly do the same thing I did last time, do SC, and then get T. So the question is, how can I get a 45-degree angle there? Well, let's just focus on S for a moment. So Q up here, C here, P here, and S somewhere. Now we've got PQ. CS is pretty important. It's 10. And 45 degree here. I'd really love it if this were 90. I don't think I can guarantee that, though. Of course, that would make this 45. No, that's almost certainly not true. Okay. So what can we do? I don't want to just have to use a whole bunch of cosine law. I'm trying to think of a nice sort of circle geometry way to do this, and I'm absolutely failing. Is there a relationship between the slopes, like there is with 90 degrees? I don't think there is. I'm not entirely sure. I'm not up on like coordinate geometry in this way, which might be a signal to me that I should study that sort of thing. And if you're in the same boat, it might be a signal to you. Maybe understand relationships between the slopes of lines with a particular angle specified in between them. I want to say there's some sort of tangent argument or something, but I honestly can't think of one. Well, okay, this 45 here and these two 10s make this isosceles. So this also has to, so the PS has to be 45, doesn't it? CPS has to be 45 degrees. All right, this 45 subtends S. Sorry, no, this 45 over here subtends PT. S subtends PT, so it should also be 45 degrees. But then we've got these two 10s here, which means that this is also 45 degrees. CPS. Does that help me? I don't know. But that would make this also 45. Which, of course, yeah, because there's another isosceles triangle there. So its CP is 45. And that might be helpful in some way. I don't quite know, though. This has me quite stuck. Not that there isn't something I could do, it's just... The only thing I can see is sort of very long and trigonometric. And, it is sort of a grade 11-12 contest. So, if you've got a trig, you've got a trig. I was just hoping there'd be an easier way to do this. And I'm really holding out hope for that. So that's what I'm going to sit here and try and think of for a second. .45s, lots of 45s everywhere. And if those are 45s, then, this guy here has got to be 90. And so that means PC is perpendicular to ST. Okay, there we go. Alright, so I can't remember what I did on the other page. I already observed in my notes ST is a diameter. Fine. Okay. Now, angles subtended by the same chord are equal. This